So what's some of the, like object storage is pretty new, and the whole being able to do things on scale out type storage is fairly new as well. So I imagine the customers that will be coming to you guys are willing to take a bet on something new, because they're not going with traditional vendors to do traditional workloads. What's one of the things that one of your customers has done that like is kind of new and funky, other than just, oh, we're trying to consolidate storage protocols? It's like, that's kind of boring. It's a great thing, but it's not sort of that exciting. Is there something that someone's doing around data analysis that this kind of solution allows them to do that they wouldn't have been able to do before?
Yeah, I can give you guys a bunch of case studies to kind of highlight some of the things we've talked about. We've sprinkled them in, but let me just step back and kind of give them as sort of end-to-end stories. So the first one I'll start with Paul Hastings. So fourth largest law firm here in the US, based out of LA. It's not a traditional big data use case. They're a very large HP autonomy shop. They have 100 million active documents. And the main SLA that they have to the business is sub 1 second queries against that database. Okay, so as Cyril Tate, who runs IT there, will tell you, the lawyers are extremely smart, but they do very stupid things. So they'll go into this 100 million document and type in damage claim and get 600,000 results, right? And so for them to hit sub 1 second kind of SLAs, they had to build out a very, very powerful indexing cluster service that actually can get into that database. And so they built that out with all Fusion IO. It was very fast, top of the line HP hardware. The problem they had is they don't ever throw an index out. So they were just storing all of these queries, and ultimately what they could do is calculate to the day when they're going to completely run out of space. And so they needed to go from locally attached storage to some kind of shared scale-out storage model underneath. So they first tried to go with a traditional storage platform, even one with, it was hybrid with flash tiers and all that, and their 0.2 second average query time jumped to 2 seconds. So they had a 10x drop in performance by taking locally attached disk away and going with some sort of network storage solution. So we came in, and what we were able to do, because of the way we can take advantage of some of those assets that they were using, we came in and provided something where it went to 0.4 seconds. But now, underneath, they have this, I'll call it infinitely scalable, but now they just roll in new nodes whenever they need to add capacity. And so they can keep that indexing service running for the business. 0.4 was an acceptable, you could think of it as a doubling of the length, but well within their 1 second SLA. And so they've built us out as the underlying scalable platform. And what was unique about us was, first of all, the economics were very compelling. They're doing this all on Supermicro underneath, right? And the second thing is that edge caching was absolutely necessary to actually maintain the performance at the application tier. So that's an example of one thing.
The one thing to add further, as your data grows, there's only that much you can scale up. The only way you can keep your SLAs capped is if you distribute and parallelize. And this naturally lends itself to that.
Yep.
And that kind of solved a very big problem for them from a latency sensitivity issue.
Yep. Yeah, so it's sort of in the short term, it's worse is better, kind of. Like we made that a little bit worse, but all of this thing is easier. And forecasting into the future, it's like, well, we know that, we know how to scale this out now, because we're not going to, presumably they have a pretty good idea of growth rates and the edge of when this thing would fall over, if ever, unlike before where it's like, we got to change things radically to be able to continue to do what we do anyway.
Yes. And here's the other thing, right? If you look at what happened in the past, people started by creating storage for their applications in a siloed fashion, right? And then the world of SAN came to be because it's one place to manage storage and everybody gets storage out of that, right? It was one monolithic gridiron box which worked very well for a long time, right? Probably still works for a slew of applications. But if you look at the applications of today and tomorrow, they're implicitly elastic, right? Now, if you want to run them, let's say in a virtualized environment, without being in the situation where you're creating these islands of storage for them again, and you want to pull them into a shared storage environment, now that shared storage environment needs to be completely different. It needs to be elastic in nature too, right? So it almost as if behooves us to have a platform of this nature in order to not create the sins of the past for these modern applications which are implicitly elastic.
Do you have other customers who are making use of that parallelizable workload that you can do with something like this that would basically you can't really do with anything else?
Yeah, absolutely. Absolutely.
Such as?
I mean, you want the name of the customer?
Not the name.
No.
But just
You can
use
anonymize
what they're
it.
doing with it.
Yeah.
Oh, so there are people running Hadoop on this, right? There are people running NoSQL databases on this. Like I said, next month we're going to have 2 guys who are going to have an OpenStack environment kind of backed by this, right? These all require one to have, it's not just scalability, right? It's also the ability to be able to self-provision into these systems, right?
Yeah.
You cannot have a traditional storage system and say, I'm going to self-provision it, right? It's a big no-no, right?
Yeah.
But these systems, like you saw how easy it is to provision. It's built into the architecture to do that, to enable one to do that.
Without going into obviously too much detail, could you elaborate a little bit more on the Hadoop workload maybe that they were doing? Because I mean, with Hadoop, you can do streaming, real time, or you can do more labor intensive, slower analytics, machine learning off of documents stored in Hadoop cluster. I mean,
So are you, just to be clear, are you asking me how they're running their Hadoop environment on top of this?
yeah,
Or-
and then
You know,
kind of elaborate, with.
Frankly speaking, we don't really care about how they use Hadoop,
Okay.
as long as they're pinning Hadoop on top of us, right?
Okay.
Example, they are using HDFS or they are
No, so they
in a
use-
convergent way.
Yeah, so what they do is similar to what people do when they use HDFS on, say, AWS. Either you put your data in S3, or you can provision EBS volumes and provide it to HDFS, right? I mean, that's what EMR is all about, and basically that's how people are consuming us. So you have HDFS, and on every server you need to have local disks, but instead of having physical local disks, you have that virtualized coming out of our environment.
And then let me just elaborate a little bit on the why, not just the how, right? So one large customer has 3 different flavors of Hadoop, right? And so they basically had these scale out islands of storage attached to each, and they had a mandate from their CTO, virtualize Hadoop. We want to go for operational efficiency. Well, they couldn't do it without a platform like this. They needed some sort of common provisioning platform underneath so that they could expose, like Avinash was just talking about. But once they thought about it, there's a different advantages once you do that. First of all, the data sets are very, very similar, even though they're running the different distributions, because heaven forbid they tell a developer you can't have the particular instance or flavor you want. But the data sets were sometimes identical or very similar. We do global dedupe across the whole cluster for them. So they're actually getting massive reduction of the data sets, even though there's logically 3 data sets in there for each instance of Hadoop. We see it as all bits, and we're able to then just virtually carve them up very differently. So they got to the CTO mandate of virtualizing. We got the dedupe. Then things got interesting when the developers were making making per instance decisions. I want, Hortonworks to be 3-way replicated in HDFS, but the MapR guy said, you know what we want to do is actually let you guys replicate. We'll turn it off on our end, and we want it replicated across data centers because this is a mission critical workload, and we want the data protection afforded to that. Now there's a latency. We can't bend the laws of physics, so we had to think smartly about the data centers that received writes versus the distant data center or cloud that gets it, right? But once you get into that kind of flexibility, and what was important is that was completely isolated from the Hortonworks guys. They were still doing their thing. And what was happening is IT was getting pressure to operationalize as much of this as possible. They all started off as departmental skunk works. Then people said, why do we have all this big, come on guys. And so the CIO got it and said, wow, there's no discipline to how we're provisioning this. We have no SLAs back to when we can carve this stuff up. We're not getting any dedupe, we're not getting any. Never mind performance, right? So they were then getting into, okay, as this thing scales, we might want to start doing things. So one thing that we could do is say, okay, here's your data set, snap it, clone it, assign totally new policies to it. So now we can just, take the Hortonworks data set, snap it, clone it, load it up to a different Horton, and it can, at that time, I can change properties. So if you weren't running it on Flash and suddenly for whatever reason you change the way you're doing analytics, you change the nature of the way the system wants to consume storage, we don't lock you into that as a decision you had to make at one time. You can kind of recover from that, right? And then the third one I'll just say is we also had an example of a customer that was simply trying to get to a point, and I just kind of touched on it lightly, but to elaborate on it, they're taking their data set and they're spreading it across 4 distinct data centers, right? So, I can't really give you the cities without beginning to give it away, but just imagine 2 cities in one country, 2 cities in another country. And what they were doing is at any point in time, city 1 wrote to city 2 and then sent city 2 across town and threw a write over the country border, right? So, but at any point in time, if they failed over or they wanted to do something or they had to, for data locality reasons, get it over to a different instance, then when they migrated over, they had to migrate the entire DR policy. Now I have to write city 1, city 2, and throw a third write over to the country, you know. Now, they weren't worried about data governance laws, so I'm not going to get into, you know, that kind of thing. But they needed a system that would switch with them and they could script it. So never mind the fact that the system can do it, they could then just automate it, and now they just have a failover button you can push that essentially forces to them, because they virtualized their Hadoops, to them it's just like a VM migration and everything just follows with it. And so they can think about that. There's other properties inside the platform around the way we do auto tiering that helps with some of the data locality issues, making sure that, right, so in our instance, we don't have any HDFS specific plugins. It's not our goal to do that yet. We'll see if customers take us there. But what we're trying to do is create a platform that has as much of the intelligence built in so that at the application layer, as you're doing things, right, the system below can accommodate that, right? And so it's often those type of things, a mandate to virtualize, a mandate to do different data protection, or they are trying to offset just the crushing economics, right? If I can get good compression and dedupe out of this, and my data set lends itself well to that, even inside of Hadoop, as these things grow, I would much rather do it on a more efficient cluster of ours. The last thing I'll say, I'm rewinding the tape going back to Paul Hastings. If you think about their environment where they had all these servers, when he was running out of the storage he was doing for all that indexing, he added a whole new server, and he got compute whether he wanted it or not, right? That's sort of the hyperconverged conundrum. You scale the two linearly. And so part of what he also got is he buys very, very expensive, $55,000 type HP class servers to do this. He didn't want to buy that when he could have been buying, at the rate he can procure things, a $6,000, $7,000 commodity server below that's running that storage cluster. And so to him, the economics were twofold. One is get it onto a more economic media to store this data, get things like dedupe and compression on those indexing, which they lend themselves well to, which he wasn't getting before. But also, now I have this value of riding a completely different economics curve. And by the way, when he's riding Moore's law. So when someone comes along and they, Intel comes out with a new processor, 8 terabyte drives suddenly hit the market and they're much more economical, then I just make sure that when I call up Dell, Supermicro, whoever my server vendor is, I just make sure that that next server is configured with those capabilities, and I ride that economics curve. And so I'm now, as best I can, offsetting my data growth with better economics. Sorry, I don't know if this is helpful, but another thing that's really unique is try doing 8 terabyte drives in an array. Right, the way they do RAID and the way traditional storage does, you'd be measuring repair time in days, if not weeks, when you try to handle disk failures. Well, our system can just take in 8 terabyte drives, and we have that container and the way we distribute. All the algorithms are abstracted. They're in software. It's different. And so now, if you do the math out, depending on who you get your drives from, 4 to 6 terabyte drives tend to be the sweet spot if you're trying to do a pure data set, right? Because performance is not what's driving you, right? But it could be 8, 10, there's even 20 terabytes on the horizon, right? And so to be able to do that, I could configure a server with a different set of disk each and every time I order them. So to be able to match the economics of the cluster to the economics of the data set is a critical thing. And then the last just kind of quick example of a customer that came to us, and it's I won't lie to you, it's a big data, but it has nothing to do with why they actually, the problem they're trying to solve. Their problem was data migration. Every 3 to 5 years, they were taking their storage arrays and they were having to go through an extremely painful task of upgrading that. And because of the growth of Hadoop, it was causing that 3 to 5 year refresh to happen faster than they'd like. And so, of course, that array vendor would call them up and say, oh, I got a much better platform for you. Right? But that data migration would take them offline for some time, and it was very painful. Well, if you think about the nature of a platform like this, think of it as an assembly line. The servers are moving this way, and at any point in time, I age out old nodes and just put new nodes in. But when I decommission a node, we just spread the data all back out, get rid of it, put a new data on, spread it all back in. So logically, my data went nowhere. Right? So you have to just think about it from a capacity perspective to make sure. But the fact that I will never do a data migration again, at least for the life of the software, and so now they're saying, hey, your software looks like it has a 10-year lifespan, as opposed to I was quickly approaching 18 to 24 months on a traditional storage architecture. Right? So, one of the things we'll often talk about is, people aren't moving. People hate change. They're not going to change for change's sake. The reason why they'll change is because either the economics or because I'm getting net new capabilities, what we see is there's a new generation of applications, and big data applications are the one that just happen to be driving it, where the nature of it is they're generating more data than ever before. And so a platform that is flexible and rides an economics curve, for another reason alone, is impetus to change. What we were asserting earlier is it's all that storagey stuff that people kind of write off as that's just storagey stuff matters. And we're at sort of a generational point as we move to software storage, which gives us all these advantages, where when you make that leap, you gave up a bunch of these things that were important. And what we're trying to do is kind of bring that back to parity. So you get the capabilities, and dedupe and compression is great for data sets, but it didn't work well, so on and so forth. So that's kind of our mission, is to help that. What we were talking about earlier is, and you guys kind of rightly called us on it, big data and data applications are not the only. There's cloud, there's virtual, there's all the traditional storage stuff, but what's different about that is I can just do things more flexibly. Some of the things that are happening in the data world simply cannot be done on a traditional sort of storage platform. But what I will say is we are a storage platform, right? So we're not up at the HDFS, we're not up in the application tier. We have a lot of customers that are doing scripting against the platform to do the analytics of their choice, and to be able to correlate that. We've even had some folks that are saying, you know what, we run at such a scale that we're actually prepared to do analytics on drive failure and predictive analytics because of how big we run. And so we're happy if you can, to Avinash's point, the data is what they needed. And so we're tracking that. We're tracking every read and write in the system. And so you can correlate, okay, we'll tell you when a drive fails. They want to know probably of a drive failing and how do I have to start migrating my data sets as a result based on this, right? So commodity is a lovely world. We all want to go towards it, but it's a completely different operational mindset. It's great that Amazon and Facebook and Google have mastered it, but how do we take it back down to average enterprises, not average, but bigger enterprises that aren't that disciplined, but are still adopting things like Hadoop and NoSQL and things like that. So I don't know if that's helpful, but that's a little bit more in terms of kind of where the platform plays relative to that. It's why one of the early use cases we've seen traction with.
So given,
I found that super helpful actually, because the question, the honest question when you're talking about another company with another storage array is, why do we need another storage array? And that's a very valid question. What you're saying, it sounds like, is that you're trying to, on the one hand, bring the innovation from this new stack, this new world of IT, into the traditional data center. But at the same time, you're also trying to bring a more traditional storage approach into this new world. So you're kind of trying to bridge the new stack and the old stack, or what did she call it this morning? The second platform and the third platform? I never heard that before, but yeah, it sounds like you're trying to build a, one device for both platforms. Is that true?
Well, see, it goes back to the question that, why, one could always ask the question, why are we even supporting iSCSI NFS, right? If I could go to everyone and ask them to change their apps to program against our API, the world would be a much better place. But we have to still support them so that we can migrate these existing applications over and not deviate from the workflow pretty significantly.
Use power.
And that's pretty,
Operational
that's realistic. The history of storage is littered with the bodies of companies who tried to convince the world to adopt their protocol or their platform. I mean, you have to go where the people are and give them what they need. And if they want block, if they want file, you have to give it to them.
Exactly.
And also, as I think we're seeing that, the Hadoop folks are really moving up the stack, and they just want, great storage underneath them, and they're going to focus on the data, not on the storage.
Absolutely.
So, that makes it a better platform for that.
Right, and I think Gartner calls it bimodal IT, but there's this concept of I have to run multiple parallel infrastructures because I'm doing Hadoop versus a different form. I've got NoSQL, I've got SQL. I'm running completely parallel infrastructures. What we do is we eliminate the need to at least have parallel storage infrastructures. You can put that commonality, which if you look at, if you charted out all the time to provision all this infrastructure, you would see that storage takes up the lion's share in terms of the manual labor. The ticketing, the provisioning, how things are done. So if we can compress that, get that common data platform, then it allows you to run those parallel infrastructures without incurring the cost multiplier of all those parallel infrastructures. That's the big goal.
But to be a devil's advocate, because I've known for that, is that I also, like I've said on Twitter, I think it also can enable just really bad accidental architectures, right? That's one of the trade-offs. So your story, which is great, is that people choose for good business reasons to have multiple architectures, multiple solutions, and need to be able to bring those things together. Sometimes they do, and sometimes they just do it because every developer chooses their own technical solutions, and then that doesn't scale, and you end up having huge support costs. So it sounds like your product can come in and help minimize those costs and simplify their architecture. And I think there's a fine balance between enabling people to continue to do that kind of things just because of a whim versus a chosen architecture. So I'm hearing both sides of it.
Yeah, that's fair. I mean, I think if there's anything Amazon taught us is that, giving developers direct access to infrastructure is an extremely interesting proposition. But I can tell you, we've got plenty of horror stories of companies that were accidentally successful in Amazon, and then they get that bill, right? And so they need to migrate that application. Well, bringing that data with it. So there's things that we can do even in those scenarios where we can help that because we're at a completely different layer. We can help so that we can help migrate, create that hybrid architecture, make it more so to your point, if you give a bunch of people a bunch of tools, they may eventually make great things. They may poke themselves in the eye. We don't know, right? But I think part of it is just giving them the platform. And then right now, I think you can correct me if I'm wrong, but I think the flexibility and see what people do with it has been sort of the front end of what we're trying to do. And then I think what we're seeing in the industry is then reining it in with reference architectures and best practices and deployment and templatizing it as much as possible. But it's sort of, first we got to see where they're going to take it before because if we just take the old templates and put it on the new platform, then it's just incremental innovation again.
Mm-hmm. So as an infrastructure company, how do you go talking to people at, say, C-level or talking about these different ways of using the storage, which is kind of new, and you're just an infrastructure company. Do you find yourselves ending up talking about just standard, hey, we want to replace your existing storage arrays, or are you having a different conversation with people around, well, here's what you could be, this is what you can do with this technology that you couldn't do before?
See, a recurring theme that we have experienced is we go and pitch the idea, and the first reaction is, we don't believe you can do all that, right? And then we decide, okay, why don't we show you what we can do? Let's start with a use case that's not absolutely critical to your environment, right? We start from there, and within 2-3 days, they are bringing use cases to the table. Once they see the simplicity and the flexibility with which they could do what they can do, right? That's been our experience. Now again, one swallow doesn't make a summer, but so far it's been working out really, really well.
Yes, and so in my world, there's two basic buying categories. There's traditional data center buyers that are thinking of us as a storage platform, and I won't lie to you, we bear the cost of educating them on the market because they're thinking of us in incremental terms.
But they have money,
They do.
And when you're a new company trying to sell something, it's a good idea to try to sell to people who have money.
Right, and they love us for backup in DR or some of the problems around provisioning because it's still a nightmare for them.
And VM integrated storage and converged infrastructure and yeah.
See, and what was the biggest takeaway from EMC World? You now have a company like EMC going there and saying everything should run on commodity hardware and everything should be driven by software. They're basically marketing for companies like us, right?
Yes.
So they are educating the market, and I think for the first time, and you guys might have seen this a lot more than I have, for the first time I am seeing in the enterprise where people are willing to look at alternative storage architectures. I don't think this was the case even maybe 3-4 years ago.
Yeah, and so that's that one camp, right? The second camp is, I just call them cloud builders. They're in charge of building that modern infrastructure, usually because of Hadoop or because of some push towards a modern elastic application that's making them think this is the whole. Those people we love. It's a very easy, we can go in there. They're educated on software infrastructure already. They've probably tried with some of the existing things, so they already know what they're looking for in a platform. And that's when, to your point, Justin, we can get to a higher, that's when we're away from the admins. It's not a storage or virtualization admin in the first camp, maybe a guy who runs infrastructure. These are people who are in charge of DevOps. These are people who are in charge of, we might even get the folks, the DBAs who are trying to sit in and make sure that the infrastructure guys don't muck up the decisions, right? So we get that, and I think you'll see us going to market. I'll give you a quick example. We were talking to one large bank. It was a bunch of infrastructure people, a bunch of storage people, and a bunch of database people, all sitting around a table. Kind of looks like
Sounds
this
like a
one.
joke.
I know.
Yeah.
They walked into a bar.
Well, at any one point in time, a third of the table was completely disengaged, and they weren't paying attention, right? Because these are not people that come together all the time. When I'm going to embarrass Avinash for a second. As an aside, he said, well, when I invented Cassandra, and all of a sudden someone popped up and said, I'm in charge of the bank's Cassandra deployment, we have to talk, right? So I won't lie to you, we can also just leverage some doors that are a little unique to us, but to go in and be able to have that conversation with, she wasn't a pure business person, but she was an IT person solely in charge of translating the bank's Cassandra needs into what it's going to be doing for them. That's, those are also audiences, but I think you guys know it better than anyone else. Infrastructure vendors can't and probably shouldn't aim for C-suite type connections. It's, half the time it's just not a productive conversation. So we're sort of going middle down, and in some cases we can go top down if we have a connection to a particular pressing need. The good news is data and storage is becoming a higher and higher business need as it shows up as a line item.
That is pleasing self-awareness to me. Those conversations tend not to go well.
Yes. Our sales guy said, good news, I got us a meeting with a CIO. And I was like, ooh, I don't know what we're going to say.
Well, let me get you to talk about some more self-awareness here. So you have a box that does traditional applications and new stack applications. It does NAS, it does SAN, it does virtualization, it does converged infrastructure, it does everything. Are you worried about trying to do everything at once?
There's actually one person in this room who really is worried that we're trying to do everything. And he is also from Hedvig, by the way. But the point is, we are, in the sense that we don't want to bite off more than we can chew. I mean, one of the problems that we constantly kind of discuss internally is that, if we unleash the software into the wild, can we actually support? Or even if we go and decide, okay, let's do hyperconvergence tomorrow, can we actually support it? Because some of the ways in which you deploy and operate them are slightly different from whatever we kind of describe in general. But I do believe that at the end of the day, it makes it simpler for the customer. So over time, we will have to figure out how we can manage everything, and I think we will. We are nervous, but we tread carefully.
And I also want to make sure we didn't overstate capabilities. We wouldn't go in and flat out replace a filer today.
So you're not going after Isilon.
Well, there's just certain capabilities that aren't in the platform yet, especially around the file locking and distributed semantics and global. There's just some capabilities. Now, you could take a virtual filer and combine it with a platform like us and come up with a completely software-defined elastic filer, but that's not built into the platform today, right? So there's some reference architectures and joint selling we see on the horizon, but to me, our one way I'd encourage you to think about it is, and somewhat's true of object storage as well, we can do it, but if you're just a hardcore archive workload on object and you just want cheap and deep storage, then maybe the economics aren't super compelling to start with us. What makes sense is if you start elsewhere and then you add that as an incremental use case later, because the cost of adding that capacity to our platform is negligible. But if you're trying to make the upfront economic decision on something, I mean, some object storage is tens of cents on the gig when you think about it, right? But it's basically like saying I just bought
Also, tens of IOPS on the gig.
Right. It's like saying I bought this nice fast sports car and I'm going to go sit and stop and go traffic, right? So maybe as long as you one day need to go fast, then you bought the right thing, and you'll just have to live it. So it's that incremental and thinking about it. So for us, it is being smart about those initial use cases. We kind of showed the 4 we have best traction, and then kind of going getting more of the use cases as customers begin to wrap their head around things and doing things operationally different.
What you just said there, I think, is an interesting point, because I've seen some other things from Twitter and like hyper-converged, and should you buy a big box, a small box, something that scales a lot, and everything else. There's trade-offs all over the place. So it sounds like with this is a very flexible solution, which can be very complex, depending on how easy it is to do and integrate with other things. But that's an investment in flexibility from what you were saying there. Is that if you know that you want to go fast today, great, then you can optimize now and say, do that. But there's also a risk of premature optimization and buying the wrong thing, like saying, well, hey, we want object storage because X. And then you go, oh, now we need it to be fast. Oh, sad face. But if you have something more like this, okay, maybe you're making a trade-off early on and slightly over-investing, but you have the flexibility now to change your mind, which is the whole point of things like cloud, is that you can be wrong and it doesn't cost you a lot of money to be wrong, and you can change your mind and be flexible and agile.
Yes.
See, the key there is flexibility and not just simplicity alone, right? Because if you go with just simplicity, then a case can be made that hyperconvergence is the most simple architecture to deploy, right? Because it's cookie cutter deployments. But then you could always step back and ask the question, I need to have the freedom to scale my compute and storage independent of each other, right? At least I need to have that choice, right? It's like you want to buy a car seat, you buy a car seat. You don't have to buy the car that comes with the car seat, right? You want to have that choice. If you want to buy a Tesla, that's fine. It's hyper-converged. You can get the car seat too, but you guys get the point, right? So.